Let's look at our last problem involving calculating a dosage by body surface area. A physician has ordered mesitoin, 150 milligrams per square meter. TID, I can't remember what that one is. Hopefully you do. PO, that's by mouth, for control of grand mal seizures. The patient is 4 feet 10 inches and weighs 142 pounds. The label states that 2 milliliters contains 40 milligrams of the drug. How many milliliters will you administer? So this drug is given to the patient as a liquid. Use the nomogram to approximate the body surface area. Okay. Well, you've got one more nomogram that shows the line that would help us determine the body surface area for this instance. Here we have information in the household system. So we're going to use the right-hand side of the scales. And we need to know the weight in pounds, which we have, and we need to know the height in inches. So we need to work out that first. 4 feet, that's 12 inches per foot, that's 48 inches, plus 10 more, that's 58 inches as the height of our patient. So in the left-hand scale, we would find the 58 figure for inches. And remember, the inches is in the right-hand part of that scale. So we find the 58 inches, we lay our straight edge over so that it hit the 142 pounds in the right-hand scale. And when we do that, in the center scale, we can read that the body surface area is approximately 1.60. Or maybe about 1.59, somewhere in there. You can see that reading those is not completely accurate. It's an estimate. So we have to understand that when you're calculating body surface area, it's not an exact science. There's some estimating involved. So if we use the 1.59 square meters, it's somewhere in that vicinity, 1.59, 1.60, somewhere in there. And the drug is given at 150 milligrams per square meter. So if the square meters cancel, if I did that arithmetic of 1.59 times 150, I'd know how many milligrams this patient should receive. But I'm giving it to them as a liquid. And 2 milliliters contains 40 milligrams of the drug. So I'll put in my conversion fraction of 2 milliliters over 40 milligrams, and that gives me the desired unit of milliliters when I'm done. So now I'm ready to do my arithmetic. I've got 1.59, which was my approximate body surface area, times 150, that was the number of milligrams per square meter, times 2, that equals 477. Divide that by 40 milligrams. That gives me 11.925. And depending upon what instrument I'm using to administer that liquid, now with liquids, we can be much more accurate. You know, if this was tablets, you can't do 925 thousandths of a tablet, and you probably wouldn't go up to the next size tablet. I don't know if you would or not. That would be a medical question, and I don't profess to know the answer to that type of medical question when it's that close. But with milliliters, we can measure, depending upon the device we're using, we can measure possibly to 11.9, but that's even questionable. If you're trying to measure to 11.9, you're probably going to get somewhere between 11 and 12. So we probably would say, and again, specifically that's a medical question, but my guess would be that you would try to measure out 12 milliliters. Because measuring out 12 milliliters, you're what? You're 1/10 of a milliliter away, that's really insignificant. There would have to be a very potent drug for 1/10 of a milliliter, I believe, to have that much of a dramatic effect. So probably you would try to measure out 12 milliliters. Maybe you are injecting this with a syringe, and you'd have a syringe that you could measure out 12 milliliters. You could never measure out 11.925. So again, this drug was based upon the patient's body surface area, which we had to determine an estimate of it using our chart. And again, see the difference? If that had been 1.60, wouldn't that have put that figure over 12? So that's an estimate. So that answers an estimate. So 1/10 of a milliliter difference can't be really that significant in calculating the dosage. Or you would use some method that was more accurate than trying to read off of a chart like this. And the other method you would use would be the formula, and if we did use the formula, we'd get a completely different answer for the body surface area than we did here. So again, it's not an exact science when it comes to calculating body surface area, and when we're needing it to calculate the amount of dosage for a patient.